All right, so this is 767, and what we're looking for is we're looking to find this V out with this op amp, and we're given that the initial voltage across the capacitor here is 10 volts. So in examining this here, we see that we know that this capacitor or this op amp, this current must be equal to 0. This current is equal to 0 because no current flows into an op amp. So we can neglect this resistor here. We don't need to worry about it. So let's redraw this circuit. And if we redraw this circuit, we have a resistor, another resistor, we have the capacitor, which is then connected to our 0 volts, ground, and then these run into our op amp. And then we have our V out over here, and then a resistor here, which is then connected to that point. And we know that the capacitor is 20 microfarads, and this resistor is 100 kiloohms, and this resistor is 100 kiloohms. All resistors are 100 kiloohms. Okay. And this voltage, we know that the voltage here must equal the voltage here. These two must be equal, and we know that this is V naught. These are connected. So this must also be V naught, this voltage here. Okay, so now let's call this, we're going to do KCL at this point, and we'll call this I1, and we can call this I2, and this I3. And we'll call the voltage there, the voltage V1. The voltage there is V1. So let's start out by KCL at that point, at node 1. So at node 1 right here, we're going to do in minus out equals 0. And coming in, we have I1, and that will be I1, and going out we have I2 minus I3 equals 0. Now we know I1 here is this voltage minus this voltage divided by 100. So that is V naught, since this is V naught minus V1 over 100. And then going I2 is just V1 over 100, and I3 is V1, this point, minus this point, which is V naught, divided by 100, equals 0. Now let's take this and multiply it by 100. We're going to take both and multiply it by 100, and we get, what's that come out to be? We would get 1, 2, 3. So 2V naught, this one, that one, minus 3V1 equals 0. So that is V1 is equal to 2/3 V naught. Okay, so we have this equation here. Now let's take a look at doing KCL at this point. At this point here. And we'll call this I4. I4. And we know that this current going in here is 0. That current is 0. So at this node here, we're going to have the equation. We have 0 coming in minus I1 going out minus I4 going out equals 0. Now, I1, we've already found what I1 is. It's this value. So we have negative V out minus V1 divided by 100. And I4, remember that the current through a capacitor is equal to C dV dt. And that's the voltage there, so that's V out there. So we have minus C, which is 20 times 10 to the negative 6. We better put 10 to the third on this one. 10 to the third, 10 to the sixth. And dV out dt equals 0. Okay. And this should be in parentheses there. All right, so let's move this to the other side. We'll move this to the other side. So we have negative 20 times 10 to the negative 6 dV dt is equal to V 100 times 10 to the third. And then let's move this over to this side, this value. So we have dV naught dt is equal, and then we'll move the negative sign as well over to that side. That is equal to V1 minus V naught because of the negative sign divided by 2. So now let's substitute in this value. We know that this is 2/3 V naught. 2/3 V naught. So if we substitute that in here, this is going to be equal to negative 1/6 V naught. And now we're going to move the V naught to the other side and the dt to the other side. So we're just going to rearrange this equation. So we have dV naught over V naught equals negative 1/6 times dt. Now with this equation, we can now integrate both sides. And we're going to integrate the left-hand side in terms of V naught. So this is going to be V at time 0 to V at t. And this is going to be integrated from time 0 to time t. And if we expand that, this is natural log of V of t over V of 0 is equal to negative 1/6 times t. And then we can take both sides to the e. So we take this to the e and this to the e here. And this simplifies to Vt over V of 0. And the right-hand side is then e to the negative t over 6. And lastly, we move this to the other side. So we have V of t is equal to V naught e to the negative t over 6. Okay. And then we know that this value here, we're given in the problem that this value is 10 volts. 10 volts there. So we'll sub that in, and we have V of t equals 10 volts e to the t negative t over 6. And that is the solution of the voltage across the capacitor for t greater than 0.